Now, let us see the first problem which is on the slide now. That is, the first problem, if A, B, C be the number of positive integral divisors of 2520 and 1800 and 2880, then the ascending order of ABC is. That is, you have to find out the positive integral divisors of all these numbers, and its number of positive integral divisors are named as small a, and the number of positive integral divisors of this one is named as small b, and the number of positive integral divisors of this one is named as c. And you have to now write the ascending order of ABC. Now let us prime factorize this. So let us divide it with 2. 1, 2, 6, 0. This is 2 into, let us divide it 4 into, that is 3 and 1 and 5. 3, 1, 5. So it becomes 2 cube now, and 3, 1, 5 means 5 into 6, 3. So it is 2 cube into 9 sevens or 63. So it is 3 square into 5 into 7. So we have prime factorized this now. From this one, A is nothing but, it can be chosen in 3 plus 1 different ways. That means it can be chosen in 1, 2 can be chosen, or 2 2's can be chosen, or 3 2's can be chosen to form the divisor, or none of the 2's can be chosen, which is nothing but 3 plus 1 ways. And it is 2 plus 1 ways. And it is 1 plus 1 way. And it is also 1 plus 1 way. So it is nothing but 4 into 3, 12, 12 into 4, it is 48 is the value of A. 48 is the value of A. Now, similarly, here it is 9 into 2 into 5 into 2 whole square, I can say. That is 10 square. Now, 2 square is here, and one more 2 is here, 2 cube is here, and it is 5 square. And you have 9 there, 3 square, and it is 5 square. So, here, this implies that B is equal to 3 plus 1 into 2 plus 1 into 2 plus 1, which is nothing but 4 into 3, 12, 12 into 3, 36. Similarly, this one can also be written like this. This is 2 into 1440, and it is 2 into 144 can be written as 12 square into 10, and it is 2 into one more 2 is there, 2 square, make it 2 square. This is 5. This is 2, 3 fourths. So 2 square into 3 whole square, which is nothing but 2 power 4, 2 power 6 into 3 square into 5 power 1, which is nothing but C is equal to 6 plus 1. I'll write directly 7, 2 plus 1, 3, 1 plus 1, 2, 7 3 is 21, 2 is 42. Now you can see A value 48, B value 36, C value 42. We need the ascending order of ABC. The lower one is B, and the next one is C, next one is A. This should be the answer. So like that, you can find out the number of divisors or factors of a given number. And for this question, the order is asked. That is, the ascending order is asked. We have made it now. Go to the next slide. And we will take an interesting problem now, which is based on algebra also. Always understand, generally, the problems can be framed like this. And whatever the problem you take, whatever the subject you take, there will be 4 levels of asking the questions. There will be 4 levels of asking the questions. What does it mean? Number 1, it is memory-based questions. Number 2, the knowledge-based questions. Number 3, understanding-based questions. Number 4, application-based questions. I can say, I'll repeat, memory-based, knowledge-based, understanding-based, and application based. Generally, memory based means direct application of the formula, and knowledge based means by memorizing the formula and by understanding the concept, we can apply that knowledge, and with that knowledge what we understand, then based on that also questions can be given. And in the application based, the concept we have learned, how to apply them. Generally, in all the examinations which you attempt in the board level, they are all mostly memory based questions. And if you go for the state level engineering entrance examination, or if you go for JEE main, now what you're going to attempt, previously it was AAA, they are generally based on memory knowledge based, and some of them are understanding based. But in IIT JEE advanced, JEE advanced level questions, you will have most of the questions application level, in advanced level questions. So 40% of the questions generally in the advanced level, you will have application based questions. So in the application based questions, generally you may be getting the questions like this. The question based on one concept, two concepts, or three concepts. Generally, the question can be framed like this because it's a combination question, and the combination concept is taken and algebra concept is taken. Both are mixed to make this problem. Like that, one more concept from trigonometry can be taken. Then the question can be formed. So generally, you have to focus like this. Whenever you will have direct questions, generally direct questions you will have on the lower level examinations. If you go for advanced level examinations, then you may be having the more than one concept questions. Similarly, now this is also a question which is based on combination and as well the algebra. Algebra means the quadratic expression. Let us see how it is related to the combination and the algebraic expression. See carefully. It's an interesting question and funny also. Mr. A has X children by his first wife. Mr. A has X children by his first wife, and B has X plus 1 children by her first husband. Okay. They marry and have children of their own. Okay, that means Mr. A has X children with his first wife, and similarly Miss B also has X plus 1 children by her first husband, and now they married and have children of their own. So how many categories of children are there? Now 3 categories of children are there. Mr. A has with other wife, he has X children. Miss B has X plus 1 children with other husband, and these two married and they have got some children, the number not mentioned of course. So there are 3 categories of children. Understand that first. The whole family has 10 children. Now how many children are there totally? Mr. A's children are X, Miss B's children are X plus 1, and they married and they have also some children. All these together there are 10 children. Okay, now assuming that 2 children of the same parents do not fight, the 2 children of the same parents do not fight, then find the maximum number of fights that can take place among the children. Maximum number of fights that can take place among the children. What do you understand by that question now? The children of the same parents do not fight with each other. That means Mr. A's children, when they are X, they will not quarrel with each other. Mrs. B's children, X plus 1, they will not also quarrel with each other. And third category children, they will not also quarrel with each other. But the first category quarrels with second category, and first category quarrels with third category, and second category quarrels with third category or first category, and vice versa. You can understand the quarrels will take place within first and second, first and third, or second and third, like that. So you have to now write the combinations by taking 2 at a time, because quarreling here in this case take place between 2 children. Okay, now let us see how many first category children are there. X are there. The first category, how many children are there? X are there. In the second category, how many are there? X plus 1 are there. In the third category, how many must be there? Because the total children are 10 minus X minus 1, which is nothing but 9 minus 2X. Understand? So first category, X children. Second category, X plus 1 children. Third category, 9 minus 2X children. Now, the quarrels among themselves will not take place. Among themselves will not take place. That means you should not choose 2 children from this one. You should not choose 2 children from this one. And you should not choose 2 children from this one, because they never quarrel each other. And we need such combinations wherein you have to choose 1 children from this and you have to choose another children from this one. So how many combinations that can be made? Total number of combinations we need, or total number of combinations, it should be like this. X is even, 1 child chosen from X children, and 1 child chosen from X plus 1 children. X is even into X plus 1 C1. They may quarrel with each other. Okay, similarly, plus X is C1 from this one only, they may quarrel with these children also. 9 minus 2X into C1. Why should we multiply? First operation, second operation, they have to perform it simultaneously or one after the other. That can be performed in M into N different ways. Principle of counting. Don't forget that. Principle of counting. So either this or this or this. Or means plus comes, and means into comes, or means or means plus comes. Either this or next, these two may quarrel. So X plus 1 C1 into this one 9 minus 2X C1. This should be our expression. Do you understand what I'm saying? 1 child chosen from the first category, second child chosen from the second category, that is multiplied, either this, first category and second category, or first category, third category, or means or means plus, second category and third category. Now let us simplify this. XC1 is nothing but X, X plus 1 C1 is nothing but X plus 1, XC1 is nothing but X, and 9 minus 2 XC1 is nothing but 9 minus 2X plus X plus 1 into 9 minus 2X. This is, now you can simplify this now. X square minus 2X square minus 2X square, X square minus 4X square, it is nothing but minus 3X square, and it is plus X plus 9X plus 10X plus 10X. This is minus 2X plus 9X plus 7X, 7X plus 9X 16X, 16X plus X 17X. And constant, where is a constant here? This is 9 plus 9. This is the expression we have got. What is the algebraic knowledge you must have here? So far what we have simplified is just applying the combination. Now this expression we have got, and understand that the coefficient of x square is negative. Coefficient of x square is negative means its graph, if you see, it should be in the reverse parabola, that is inverted parabola. Inverted parabola, you will have the maximum point. That means we need maximum quarrels in this case. So you have to find out the maximum value for this one. Maximum value for this one. You might be knowing the maximum value. The maximum value is, then you may get doubt, sir, why should we have maximum value only? Because whenever the coefficient of x square is negative, you will have only maximum value. Whenever you have the coefficient of x square positive, then it will be U-shaped parabola, that is upward parabola, we can say. For an upward parabola, you will have only the minimum value. So whenever the coefficient of x square is positive, then you will have minimum value. Whenever coefficient of x square is negative, you will have maximum value. We need the maximum value, either maximum value or minimum value. You might be knowing the formula. It is 4ac minus b square upon 4a at x is equal to minus b by 2a. Might be remembering. at x is equal to minus b by 2a. That is, x value is minus b by 2a, but we need maximum quarrels here. So in this case now, it is 4 into minus 3, minus 12 into 9, it is minus 108, minus b square, minus 17 square, minus 289 upon 4 into minus 3, it is minus 12. What should be the value now? It is nothing but 987, and this is 17, this is 9, and it is 3 upon 12. So it is nothing but 3, 37, 33 point something you will get. 33 point something you will get. So we need the number of quarrels, mean it should be an integer. So take the integral part of it. Integral part of this, that is step value. If you take the step value, it is 33 quarrels. Maximum number of 33 quarrels takes place, not more than that. So that's an interesting problem. Understand the combination applied, and later on the algebraic knowledge of the quadratic expression applied. This is very important model. Think of it, the problem looks very long and lengthy, but if you apply, if you while attempting such type of problems, always split the problems and think of it. Split sentence wise and think, and then apply the algebra. Conversion of word problems into algebra goes like this. Okay, now even if you do not remember this formula, then also you can apply it through the derivatives, because it is a maximum value. You might be knowing how to find out the maximum value or minimum value of any polynomial, algebraic polynomial. Of course, in this case, it's a quadratic polynomial. So if you want to find out the maximum value without knowing this formula, then also you can find out if you know the application of derivative. In that one, you know the increasing, decreasing functions. Later on, you will have maxima and minima. How to find out the maxima and minima? Let me briefly explain that. Without using the formula, the maximum value occurs or minimum value occurs. That is, the least value or greatest value occurs only when dy by dx equal to 0. Understand, please. Dy by dx equal to 0 implies it is minus 6x plus 17 equal to 0. Minus 6x plus 17 equal to 0 implies x is equal to 6 by 17. X equal to 6 by 17. That means at the value of x 6 by 17, y will have maximum value. Alright, this is the point where y takes maximum value. This is x value where y takes maximum value. Therefore, how do you get y here? Y is equal to minus 3 into 36 upon 289 plus 17 into 6 upon 17 plus 9. If you simplify this, you'll be getting the same value. This is the other way of understanding it. So not only that algebraic formula, if you better remember the application of derivative, that is finding the maximum and minimum value, through that also you can find out this. Okay, now let's go to the application 2, that is, which is a very, very important part of the combinations. That is, here the number of non-negative integral solutions. Understand that please carefully. The number of non-negative integral solutions of x1 plus x2 plus x3 plus so on plus xr is equal to n, is n plus r minus 1 cr minus 1. Next, number 2, the number of positive integral solutions of x1 plus x2 plus x3 plus so on plus xr is equal to n, is n minus 1 cr minus 1. But before explaining that, let me first tell you the number of non-negative integral solutions means 0 solution also included. The number of positive integral solutions means you have 0 not included. Only positive integers should be taken. That means in the first case, it starts from 0, 1, 2, 3, 4, 5, so on. In the second case, 0 excluded. It starts from 1, 2, 3, 4, 5, 6. Okay. Now, for example, you went to a temple or any sacred place. You may be finding some 10 beggars outside the temple or outside the mosque or outside the church or outside the Gurudwara, whatever it is. And let us suppose there are 10 beggars and you have got some 8 coins in your hand. 8 coins in your hand. 8 coins in your hand. Then you want to distribute the coins to the beggars. Then in what way you do that? In what way you do that? Just think of it. You may be thinking like this, or each beggar must be given 1. But there are 10 beggars and you have 8 coins in your hand, similar coins, like 1 rupee coins, let me say. Then in such a case, you are distributing randomly. You are distributing randomly. Then you may do like this. You can give all the 8 coins to a single beggar. And you may give 7 to one, 1 to other. You may give 6 to one and 2 to other. You may give 6 to one and 1 to one and 1 to third one. Then if you distribute like that, what about the remaining beggars? They will be getting 0 rupees. They will be getting 0 rupees. That means for this one, how the solution is in this case, how the distribution will be like, it starts from 0. One beggar is not getting any amount, then that means he is getting 0. And one beggar is getting 1 rupee. Let me say it is 1. One beggar is getting 2 rupees. It is 2. One beggar is getting, let me say, 3 rupees. Then it is 3. Then what should be the maximum value? It should be 8 only. If you give all the coins to a single beggar, he will be getting 8 rupees. That means the distribution takes place like this. Either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. It's nothing but the distribution of similar coins. Understand that? Okay. Now, let us take an example for that one for your better understanding without applying that formula so that you will better understand what should be done while attempting such type of problems. Let me say x1 plus x2 is equal to some 10. It's an algebraic equation. Now, I want to write the number of non-negative integral solutions. Then I'll start like this, 0, 10. It's one solution. 0 plus 10 is 10 only. It is 1, 9. It is also 10. 2, 8. 3, 7. 4, 6. 5, 5. Next, it goes like this. This will come this side, this will come this side. Understand? Just they will be interchanged. So what should be this one? 6, next 4 and 7, 3, 8, 2, 9, 1 and it is 10, 0. So how many positive integral solutions do you have? How many non-negative integral solutions do you have? Non-negative matlab 0 also included. Non-negative in this case, or you can understand 11. And positive integral solutions in this case are excluding 0. These are only 10. Understand please carefully. Now, this is with all common sense. Everyone can do this, but we need an application in the combination. Then I'll do like this. How many are there here? 10. And how many variables are here? 2. So 10 plus 2 minus 1. C 2 minus 1. Then how do you write this, sir? How do we understand this? I'll explain you that. Just wait. And this is 10. 10 can be written like this. 11 minus 1. This is, count this. 1, 2, 3, 4, 5, 6, 7, 8, 9 are there. Not 10. 9 are there. 9. So I'll write this in this way. 10 minus 1 C 2 minus 1. Understand it? Understand it carefully. This is 12 minus 1, 11. 11 C1. 11 C1 is nothing but 11 only. And here 10 minus 1, 9 C1 is nothing but 9 only. Do you understand? So if I give you a general equation like this, x1 plus x2 plus x3 plus so on plus xr is equal to n, You need the number of non-negative integral solutions. Non-negative means 0 included. In place of 10 you have n. In place of 10 you have n. In place of 2 you have r minus 1, c, 2 minus 1. This is 2, this is r. This is r minus 1. Number of non-negative integral solutions. Next, positive integral solution from this one. Positive integral solutions. In this case, it is 10 minus 1. It is 10. It is n. It should be n minus 1. C. It is 2 minus 1. 2 minus 1. It is r. R minus 1. Then you may simply think like that. Sir, you are making it some magic here with the numbers and all. But you have the derivation for this one, and you can derive this using binomial theorem. You can derive this using binomial theorem, and we have to find out the coefficients there in the binomial expansion. For that one, we need the knowledge of binomial expansions, and whenever we start that topic, binomial theorem, then again we will discuss how these are derived and how that can be applied to the combinations. At the time we will discuss. But for the moment, we are mainly focusing on JEE main, wherein you will be getting some straight questions like this. Then for those questions, this will be useful. So understand, please, the number of non-negative integral solutions includes 0 is nothing but n plus r minus 1 c r minus 1. Here r terms are there, here n terms are there. Sum of all this is n. Like what? There are 10 beggars and you have 8 coins only. 10 beggars, you have 8 coins only. That means if you add all the coins with the beggars, then you'll be getting the number of coins. Like that. So, similarly, here positive integral solution is n minus 1 c r minus 1. So, you can better understand this whenever you do not understand this type of things. You take an example and think of yourself. Then your logical thinking will be improved. Let's see a problem on this one. If you see, the first problem there. The number of integers x, y, z, w such that x plus y plus z plus w is equal to 20 such that x, y, z, w is greater than or equal to minus 1. Now, if you say this carefully, x1 plus x2 plus x3 plus x4 is equal to 20. And if you want to apply that non-negative integral solutions or positive integral solutions, it's not possible because x may be minus 1. Y may be minus 1, Z may be minus 1, W may be minus 1. To apply that formula, it must start either with 0 or with 1. Understand? Either with 0 or with 1, but it starts from minus 1. So let us make a little modification like this. What we do now we will get this to other side. Then what will you get? X plus 1 comma y plus 1 comma z plus 1 comma w plus 1 in this case is greater than or equal to 0. Understand this please carefully. Understand this. So to apply that formula comfortably, the restriction to be fulfilled is it must start with 0. So if it is x, then we cannot apply that because x is greater than or equal to minus 1. If it is x plus 1, we can comfortably apply because it starts from 0. So what I do now, I'll add 1 to each of the terms. Then what happens? That becomes x plus 1 plus y plus 1 plus z plus 1 plus w plus 1 4 added on left hand side, that is why on right hand side also 4 is added, it is equal to 24. Now you can consider this as x1 plus x2 plus x3 plus x4 is equal to 24. Now your common sense works out here. What does it mean? Whether to write non-negative solutions, non-negative integral solutions or positive integral solutions. Non-negative integral solutions or positive integral solutions. You can understand. Non-negative integral solutions means it must start with 0. So, it should be the formula n plus r minus 1 c r minus 1. What is n here? It is 24. What is r here? 4 minus 1 c r 4 minus 1, it is 3. So it is 27c3. It is 27c3. If you simplify this, you'll be getting 27c3 is the answer. Fourth option, you can clearly see that. So whenever the direct problem is not given, direct application of the formula is not given, you have to modify like this. And of course, these problems can be solved using the coefficients also, where we need the knowledge of binomial theorem, their expansion and collecting their coefficients, all this we need. Okay, now coming to the next problem, the number of ways of selecting 10 balls out of an unlimited number of white, red, green and blue balls. So when you go through such problem, you will literally be confused, because in the question, it is given that unlimited number of balls are there. Unlimited number of white, red, green and blue balls are there. Then you may be literally confused. Unlimited number of balls are there. How to choose 10 balls out of them, and how many number of ways we can select 10 balls from them. But we have to take only the category here. What is the category here? White balls and red balls, then green balls, then blue balls, and totally they must be 10. Totally they must be 10. So white plus red plus green plus blue is equal to 10 now. Now apply the formula. It is x1 plus x2 plus x3 plus x4. In this case it's 10. And whether to apply a positive integral solution or non-negative integral solution, it is your common sense. No restriction is given there. No restriction means you can take all white balls, all red balls, all green balls, all black, all blue balls, isn't it? Now if you take all white balls, these will be zeros. If you take all red balls, remaining will be zeros. If you take 9 white balls and 1 red ball, then these two will be 0. If you take 8 white balls and 1 red ball, 1 green ball, then this will be 0. That means 0 solution also included. That's what I mean to say here. I want to make you understand that 0 solution also included. 0 solution also included means it is nothing but n plus r minus 1 c r minus 1. Understand that, please. Now, what is n here? 10 plus 4 minus 1 c 4 minus 1, which is nothing but 14 minus 1 13 c 3, which can be simplified to be 12 into 13 into 12 into 11 upon 3 into 2, which is 2 times, and it is 13 into 22. If you simplify that, it enters 26, 26 plus 228, 286 should be your answer. Fourth option. Okay, go to the next problem, the next slide. The number of ways in which an examiner can assign 20 marks to 4 questions, giving not less than 2 marks to any question. Giving not less than 2 marks to any question is the number of ways in which an examiner can assign 20 marks to 4 questions. How many questions are there? 4 questions are there, and here also the restriction is there. That is why to apply this formula, you have to understand that the restriction should be fulfilled. What is the restriction here? How many questions are there? 4 questions are there. So Q1 plus Q2 plus Q3 plus Q4 should be what? It is 20 marks. But what is the restriction there? Not less than 2 marks to any question. Not less than 2 marks to any question. Not less than 2 marks to any question means each question must have at least 2 marks. Then you can distribute whatever the number you like. So what we do, we first of all fulfill the restriction. What we do, we are allotting 2 marks to this one, 2 marks to this one, 2 marks to this one, and 2 marks to this one. Then what happens? We are distributing 2 to this, 2 to this, 2 to this, 2 to this to satisfy the restriction. Distributed 4 into 2, 8. So 8 marks are already distributed. Then what we do, we just distribute those marks that are subtracted now. That is, because 2 marks each is allotted, now sum of the marks to be distributed, the sum of the marks to be distributed will be 20 minus 8 only. That means why we are leaving 8 marks here? We have given already 2 marks each to each question. Now our n will be here 12. Now common sense again. Whether we have to apply non-negative integral solution or positive integral solution. Non-negative integral solution or positive integral solution. What is non-negative integral solution? Zero solution also included. So in this case now, because 2 marks are already given, you can give 0 to this. Because 2 marks are already given, you can give 0 to this one also. That means 0 also included. So here also it is n plus r minus 1 c r minus 1, which is nothing but 12 plus 4 minus 1 c 4 minus 1, which is 15 c3. What is 15 c3? 15 into 14 into 13 into 3 into 2, it is 5, it is 7. You can, if you simplify, you will get the answer. If you simplify, you will get the answer. You can count it. Similarly, the next problem, please. The number of ways in which 13 gold coins can be distributed among 3 persons such that each one gets at least 2 gold coins. What do you do then? Then how many persons are there? 3 persons are there. You consider only P1 plus P2 plus P3. Should be equal to 13. If nothing is given, it should be equal to 30. But the restriction is each person must get 2 coins. So first of all, what we do, 3 persons are sitting before you and you'll give 2 coins to first person, 2 coins to second person, 2 coins to third person to fulfill the restriction. What is the restriction? 2 coins must be given to each of the persons. So 2 coins are given. So how many coins are distributed? 6 coins are distributed. How many total number of coins are there? 13 are there. 13 minus 6 is how much? 7. So those 7 coins only will be distributed to 3 persons. What does it mean? P1 plus P2 plus P3 is equal to 7. Then you have to apply the same formula to get the positive non-negative integral solutions, because 0 coins can be given to a person because the restriction is already fulfilled. Okay? Go to the previous slide. Again. Yes, that one. Now, this is for your homework. Please see that one. You write that question, please. Write that question. A lift with 7 people stops at 10 floors. A lift with 7 people stops at 10 floors. People varying from 0 to 7. People varying from 0 to 7 means non-negative integral solution. 0 is also included. That means, let us complete it. People varying from 0 to 7 go out at each floor. The number of ways in which the lift can get emptied, assuming each way only differs, the number of people living at each floor is. What does it mean? How many people are there? 7 people are there. How many floors are there? 10 floors are there. And these people may descend or may go out of the floor or may not go out of the floor. That means all the people may go to only one floor or no person will go to some floor. That means it ranges from what? 0 to 7. 0 to 7. Then you can get the answer straight away. straight away by using the non-negative integral solution, because you can understand is zero solution is also included. Zero solution is also included. So it is now you can understand the application of the non-negative integral solutions and positive integral solutions, how they are to be applied. Go to the next continuation. X. Okay, leave it off. Now, some more we can discuss mainly the dearrangement. Dearrangement. It will be written like this: derangement. Both are same. I have separated this for the better understanding. Dearrangement. What does it mean by dearrangement? Simple. I'll tell you an example. Like there are 5 different colored boxes, and there are 5 balls of the same color. Do you follow me? 5 different colored boxes. Let me say black, yellow, red, green, violet. Let me say these are the boxes, and you have the same colored balls. You have the same colored balls. Balls are also of the same color: blue, black, yellow, red, green, violet. Now you have to distribute these balls in such a way that the ball of the same color should not go into the same color box. Do you understand what I'm saying? These are the boxes of different colors and the same colored balls are there, and now you have to distribute these balls into the boxes in such a way that the same color ball should not go into that particular box. That means black should not go into black, but it can go to any one of the 4. Yellow should not go into yellow, but it can go into any one of the 4. And red should not go into the red, it can go into any one of the remaining. Like that, if you can arrange, then we'll better understand what is a dearrangement. That is said to be dearrangement. Dearrangement means the same colored ball should not go into the same colored box. And in other way, let us suppose there is a boy has 3 girlfriends, and he wrote letters to 3 girls. 3 girlfriends, he wrote letters to 3 girlfriends, L1, L2, L3, and he prepared envelopes also for the corresponding letters to be kept. Then he has given it to his friend, and he asked him to keep the letters in the envelopes. Then in how many different ways he can keep? He can keep them in 3 factorial different ways. What does it mean? This is L1 E1, L2 E2, L3 E3. Always keeping the right letter into right envelope is only one way. Remember, 100 envelopes are there, 100 letters are there. You can keep 100 letters into 100 envelopes only in one way. Right way is always one. Wrong ways will be many. Generally in your life also, whatever it is, right way, right thing is always one only, and the wrong things will be many. So here, and L1 E1, L2 E3, L3 E2. L1 E3, L2 E2, L3 E1. Here L1 E2, L2 E1. You can see only one letter has gone into the right envelope. Only one letter has gone into the right envelope. So remaining L1 E2, L2 E1, L2 E3, L3 E1, and L1 E3, L2 E1, L3 E2. You can see these 2 cases. In these 3 cases, one letter is going into the right envelope. In this case, all the letters are going into the right envelopes, but in this case, no letter is going into the right envelope. This is nothing but the de-arrangement, understand? This is nothing but the de-arrangement. So, for the de-arrangement of the things, you have a directive formula that is de-arrangement is equal to of n addressed envelopes and n letters are there, then it is nothing but n factorial into 1 minus 1 upon 1 factorial plus 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial minus so on plus minus 1 whole power r or n upon n factorial is the general formula. Or you can rather, it can written in the sigma notation. This is n factorial into sigma minus 1 whole power r upon r factorial. R runs from 0 to n. That means if you have 3 envelopes, 3 letters, n is equal to 3. Up to this it comes. Up to this it comes. Then it will be only 2. Just now I have shown you. Only 2 de-arrangements will be there. And 4 envelopes, 4 letters. It will be 9. 5 envelopes, 5 letters. It will be, you'll get some 44. 6 envelopes, 6 letters. You'll get some 265. Better if you remember this, you can straight away write the answer instead of applying the formula and simplifying. If you remember this will be good. This will be good. So understand. So this is nothing but the de-arrangement. So let us take a problem. There are 6 married couples attending a party. And attending a party, then the condition is they have to dance with the other person. They have to dance with the other person, other gender, in such a way that no wife should dance with her husband. No wife should dance with her husband. Do you understand? 6 couples are there. 6 couples means 6 husbands, 6 wives are there. And let us suppose wife 1 is there. Wife 1 has husband H1. Then wife 1 should not dance with husband 1. She can dance with any one of the remaining 4. Then in such a case, it is nothing but a de-arrangement. 6 married couples are attending a party and they have to dance in such a way that no wife should dance with her husband. It is nothing but 6 envelopes, 6 letters arrangement. So the answer for this one will be 265. Understand it? So otherwise, if you want to apply the formula, instead of remembering this, you can apply this. N is equal to 6. It goes up to minus 1 by 5 factorial plus 1 by 6 factorial, like that. Okay, this is nothing but the de-arrangement of things.